So welcome to this Make Your Data Work Monday. If you've got any questions at any point, please do ask. I'll be happy to take those. I want to say thank you for attending. And in today's session, we are going to look at RStudio. We'll have a walk through some R code, and we will then have a look at the same data in Power BI. So let's get started. I'm assuming that people are not familiar with RStudio or R. So we will start at the beginning. Now this is RStudio, and underlying RStudio is the R console. And the console you can see down here, this part. So the console is like the brain of R. This is the part or the engine that actually does the work. This is our file here. Now don't worry about trying to read the data too much. At the moment I'm going to take you through it line by line. So this is where our files go, and you can see these are in R format. Over here in the right hand side, we have some configurations which help RStudio to work. So the first thing we've got here is the environment, variables, and we've got our data sets here. We're accustomed to thinking of data sets as similar to tables in a database, or a data set can be considered to be like a data set in reporting services, or a table in Excel, which has rows and columns of data. And what we have here is the ability to see we've got 5 data sets here. We're going to walk through those. Now, we have the ability to record R commands as we go, and that's what these are. So don't worry too much about reading those. Those are just practice commands I've been running earlier. And we've also got connections in here, so I could set up new connections if I want. If we've made any plots, those plots go here. Now we can install additional packages, and I'll take you through this. R is open source, and it provides a whole bunch of packages that we can use in order to help make our data work better. There's also a great facility for help here. And we've also got the viewer as well, and that allows us just to view various files. So what I'd like to do is start to take you through some of this code. Now if we want, we can actually install new packages, and there's an install button just here, and I can install some of the R packages. So ggplot2 is one of the main graphics visualizations that we have access to using R. It's a very popular one, and if you like data visualization and you're interested in getting started with R, having a research of the ggplot2 is an excellent way to get started. So I'm going to install that, so I click on install. I'm not going to restart it, I'll just kick off the installation. You see ggplot2. Now that is the R command for what we just did here with the install command. So I've got packages, and these are dplyr. Now dplyr, I envisage that as being like a plier for data. It helps us to do data preparation work, and it's very important for really getting to grips with some of our dirty data. So that's installed. Grid Extra is another package which helps us to install and view the data better. So I'm going to install that one too. Grid Extra, install, all done. So the next step that I'd like to do is call these libraries, and that's what this code here is doing. If you're familiar with Visual Studio or anything, or Python, for example, you can call different libraries or packages to help things work. So I'm going to click on one, and those libraries will be called. So what I can do is write out this data. We will be using the diamonds dataset, and we'll come back to that later. I want to use the CSV file in Power BI. What's going to happen here is that's going to view that as a data frame. So a data frame is one of R's way of viewing data and storing it. It's internal to the R language. So what I'm going to do here is take the diamonds dataset and I'm going to create a data frame out of it. That's going to make it more efficient from the R perspective. And I'm going to assign it to a new variable. And that new variable is called diamonds data. So when I press return, that's going to create a new data store called diamonds data. Now I can view that data frame here. And what we can see is that the data frame itself has a number of columns about diamonds. It's got the carat of the diamond, the cut, the colour, we know the clarity, how clear it is, and then depth gives us an idea of the size. We've got the table information is price, and then we've got X, Y, and Z. Now X, Y, and Z are not very clear in terms of the terminology, so that's what diamonds data looks like. And then we're going to look at the head command actually gives us the top 6 rows of the data sets that we're looking at. And here down the bottom, we have those top 6 rows. We can see our columns here with X, Y, Z in them. And we can see the actual data as well. Whether the cut of the diamond is ideal, premium, good, so on and so forth. And we can see the price in this column here. We also have the tail, and the tail is going to give us the bottom 6 rows. And that's going to tell us how many rows we have in our data set. But what we could do is use the dim command. And what the dim command is going to do is it's going to tell us how many columns we have, which is 10, and we know that by counting these. And it's going to tell us how many rows we've got. 53,940. Now that's quite important because that would help us to understand if our data was missing or not, for example. So what we have now is the dim command is very useful, and it might remind you of a dimension if you are used to using data warehousing terminology. But what we don't use it for here is data warehousing. It's just telling us the dimensions, i.e. the rows and column size of the dataset. So what we're going to do is rename these columns here, X, Y, and Z. And we're going to also rename column number 5 as well. So instead of reading depth, it's going to read depth perception. So to do that, we use the names command. And that comes from dplyr. So we give it the dataset name, and then we give it the number of column that we're looking at. So this column, X, the 8th column, is going to be renamed as length. So if I run that command, what we need to do is have a look at how the data looks. It's quite fast to rename those columns. So what we see now is that we have got the columns here, but X, Y, and Z, columns 8, 9, and 10 have been renamed, and the depth column has been renamed to depth perception. So we can use dplyr for a number of really useful commands. One is, for example, we could use it for piping the data. What that's going to do is going to, first of all, give us the count of each cut of data. So we're going to start grouping the cut of the data, whether it's ideal, premium, good, so on and so forth. Then we're going to summarize it. So we're going to count the instances or the rows of data, and then we're going to count the total carats overall. So these little bits of code are really useful for helping us to finesse the data. So I will run this command and then be a bit easier to see how it looks. So diamonds data is the main data set, which gets piped through into a group by command. If you're accustomed to using SQL, you'll be accustomed to using a group by. And we are grouping the data by the cut. Fair, good, very good, premium, or ideal. Then we're going to summarize the number of diamonds that actually have each cut, whether it's fair, good, very good, so on and so forth. And then we're going to use total carat. So we're going to sum the number of carats in total. So we have 1,610 fair diamonds, and the total carat for that is 1,684. Okay. So we can repeat the same command. This time we use the cut of the diamond. This time we could group it by the color. So what we have here is the total count of diamonds, and we have the gradation of color. So diamonds come in different colors, so pink, sort of clear color, and so on. So these are grouping them by the categorization of the color of the diamonds. So what we see here is that 6,775 diamonds are designated with the color D, and they have the carat 4,457 in total. So what we can now do is now we have our data. So now we have our data, we can start to create subsets of the ideal diamonds. And these will create new data sets, which will be assigned to new variables. So we'll have the ideal data set, premium, and very good. And these will be assigned to new variables. So when we can start to go through our global environment, we can see them over here. They're in alphabetical order. So I ran these earlier, so we see where they appear. But what I'm going to do is I'll run the command again, so you can see it. So when I run the command, say for head diamonds ideal, we can see that the diamonds appear for the top 6 rows of the ideal diamonds. We have the information associated with them. When we execute the diamonds premium command, we get the head of the data as well, the first 6 rows of premium diamonds, and we have the information here. And the same for very good. So if we want to see the full data set, for example, of ideal diamonds, we could click on the variables over here. And what we see here is we have our data set. We can see at the bottom of our studio, just here, it says there's just over 21,000 entries of 10 total columns. So if you ever want to see the data sets, you can see them in here as well by clicking over the environment. So I'll just save that file. Now, if you are familiar with SQL, you might be quite familiar with this command, which is the select command. As we know in SQL, we can use select to identify which columns and which data we are looking for. We can also filter. So in this example, we can create a new data set called diamonds. We can create a new data set which we can call perfect diamonds, and that's only going to use diamonds in this context here of this select command. So perfect diamonds is going to take data from the very good data set, and what I think we need to do is take that data from the diamonds ideal data set. What that's going to give us is the ideal data set. This information here, so we're not using all of the columns, we're just taking 6 of the columns here, and we're going to assign that data result to the variable called perfect diamonds. So I'm going to select return, and when I select the run button, it gives us our results. So now I could go and have a look at perfect diamonds, which will appear in here, and I can see the data appearing here in this data set. If I just want to see a little bit of the data, I can use the head command just here, and that gives us the top 6 rows of that data set. We can also filter the data as well. So this is going to give us no change because the cut of that is already for ideal diamonds. So that's not going to change. But we can use the filter command, which is a bit like a where clause. So what we could do is we can filter perfect diamonds, and instead of cut, we could give it color. And the color is going to be E in our example. So I could call that perfect diamonds E, color, and that will give us a new data set of perfect diamonds that have got the color E. So now if I want to see the top few rows of that data, I'm going to execute that command. What we see here is I've got diamonds data, color E, been assigned to that variable, but I can change that so it's not looking at diamonds data, but instead it's looking at the perfect diamonds data set. And then I can execute that command again. This time the data is going to change. It's only going to be diamonds that have got the ideal cut in the ideal color E here. So what we've got here is the ability to really refine the data down that we want. So earlier we had 51,000 plus rows. So let's see how many we've got now in our perfect diamonds E-color dataset. Now we're down to just less than 4,000 rows here. We still have the same number of columns. So we can start to use R like SQL in order to get the data exactly that we are looking at. So we can add new columns to the original perfect diamonds dataset. This is going to add in a new column, which is going to give us the price per carat, which is basically the price divided by the carat. Up till now, we've had 10 columns, but this is going to add another column. And the new column is going to be called price per carat. So how can we see that? Is we can emit the head command again, we transmit that. And what we see here is that we have the price per carat appear as a column here, which gives us an additional column. We could also sort as well. Now, if you're familiar with SQL in Power BI or Excel, you're accustomed to sorting data. We actually have the same facility in R, but it's called arrange. And this comes from the dplyr package as well. So now if I run this command, it's going to sort the data in descending order by price per carat, which is the new column that we just created a moment ago. So that seems to have worked, but let's just double check the results. So now if I run that command, you can see down the bottom here that the price per carat is indeed in descending order. We can also get the mean of the column, so when I execute this command, it's going to give us the mean of a particular column, and this time it's going to be the price. And the next thing we could do is summarize the data. We're going to summarize the data, and we're going to get the average price, which will be a new variable, and that variable will be the median of the price, and we're going to ignore nulls. So this piece of code here is going to tell us to remove any rows which have got nulls in them when we are collecting, and it's going to remove any rows which don't have any nulls. It's going to remove rows which have got nulls in them, and when it's calculating the price. So null rows will not be included when the average price is created, and we know that because this little command here tells us that. So the next step is to get the median price of a column, 2,401. And we can also get the median as well of the price. We can do some other commands like get the min and the max, and those are quite useful to know. We can also get the standard deviation of the column using the SD command. See if that works. Oops. Oh well, I'll just leave that. So now we can print out our deal as well. And that basically just prints out the information to the screen. We can also summarize the data as well using the summary command. So if you're familiar with SQL, it would probably take some time to go through and produce this summary information. But say we take price, for example. We've got the minimum, the maximum, the median, the interquartiles here, and we've also got the mean as well. So we can also set up a new data set, diamonds data J, where the diamonds are assigned to the color J. And we can see that data too. So now we've had some good fun looking through some of the opportunities for fixing data that we can see using dplyr. But let's do some data visualization as well. This is the ggplot command here, and we're going to give it the J dataset where diamonds are the color J, and we're going to specify that we are going to use the price will be the color. On the y-axis we will have price, on the x-axis we will have the caret, and we're going to look at the relationship between the caret and the price of the diamonds. We're going to do some gradation as well between red and blue, just so that it looks nice. We can also add in some labels here, so I can change that and it will be diamonds plot. And that will tell us what the data is going to do. And then we can plot that data. I don't know if you remember, but we're going to plot the data over here. So we should see the plot appearing there. So while that code is running, I'm just going to double check to see if I have got any messages or any queries, if anyone's hand is raised. I don't see any Q&A at the moment. If you've got any questions, please do shout. I'm going to put my email address in here. If anyone's got any questions, so you can take a screenshot of that if it helps. So here is a plot here, and what this is going to do is going to give us visualization. We have got the J color diamonds, but we have categorized each of those diamonds by the carat and the price, and we can see the information there. So there is, as you might expect, an upwards trend relationship between the price and the carat. So the more refined the diamond is, the more likely we are going to see that it has an increase in price. So we can play around with the diamond set in Power BI as well. So now we have the diamonds data in its original format. We can see the carat, the cut, color, the clarity appears again, depth table, so on and so forth. So I'm just going to load this data. We can try and have a look at R again, and we can replicate some of the steps that we saw in R back in Power BI. So length, width, and depth was how we renamed our original columns. To do that in Power BI, we have got the data command in here. So we could do it in here. The other thing we could do, we could have renamed and transformed it in the rein, so that was the length. I'll just check width and depth. And then the depth again. So it's depth perception. So this one is called depth perception. I'm going to change that. and then I can change this column to be depth. Now it looks more like what we had in Power BI. So what we can do, I can go back to home and I can transform this data using Power Query, and we can do some of the same things in Power Query that we did in R. So when we hit the Transform Data button, you can see that we've still got our columns here and our renamed columns have been preserved. So we can do that. So what we can do is filter data in Power BI. What we can do is we can categorize by color, for example. We could filter in here if we wanted to. We used the colors E and the colors J, but we'll leave those the way that they are. And we could also add in another column as well. So we divided price by length and price by carat, so we could do that as well. So to do that, I'm going to add a column, and I'm going to add in a custom column here. And I'm going to call it a price by carat. So I'm going to take the price column, carat column here, and that should work. So now I'm going to, this is quite a simple piece of Power BI, take the price divided by the carat, and then I'm going to click OK. So we've got price by carat here. It looks a bit confusing because it's in the whole number format. So what I'm going to do is click on the Home tab and change the data type. You can see the data type is set to any, and I'm just going to change that to a whole number so it looks a bit better in terms of the visualization. So what I'll do now is I'll close and apply, and that will commit that change to Power BI. Those changes will be applied, and we're still in the data format here. So I can see price by carat appears just here. So we've added in our new column. Then I can click on the canvas for Power BI and start to make changes here. So in our chart originally, we had price, and then we had price per carat is the visualization. It's actually more like the color, which I'll leave there. And we've also got the carat as well. So what we could do is use that in a line chart. It's got price per carat here, but then we could start to add in the cut into the axes. So what we see here is ideal, premium, very good, good and fair is what we kind of expect to see. But it doesn't look very good because a line chart isn't the best way of displaying this data. If you joined me last week, you might remember that we talked a little bit about data visualization and how we can use different ways of representing data to get the right message across. So if I click on this, now do it's a bar chart, now it starts to look easier because these are distinct categories. So we shouldn't be using a continuous line chart to represent those. So that gives us ideal, premium, very good, and so on and so forth. Alright, so that gives us some different ways of visualizing the data. Next week, we will be running at 6 o'clock in the evening. I'm trying to catch people at different times. If you've got a preferred time, please let me know. I'm still working out how Make Your Data Monday might work, and I'd be glad of any of your feedback or comments, what's working for you and what's not working for you. I'm trying this out in a very agile fashion, so I'm very glad to have any ideas or thoughts that you might have. So with that in mind, I hope you enjoy the rest of your day, and thank you very much for joining me today. And I'll end the webinar from here, so thank you.